Hi everyone, welcome to lesson 44 of our trigonometry unit. Today we're going to take a look at the difference between vector and scalar quantities. What I'm going to do today is I'm going to do all my edits in my Google Doc, and you can follow along with that. Or if you're more comfortable, go ahead and print your document, and then you can fill it in with a pen or a pencil as we go through the lesson. So let's take a look. Vectors and scalars are both important concepts in physics and math. A scalar quantity only has a size or a magnitude, something like a distance or speed. A vector quantity has both a magnitude and a direction. Examples of those are displacement and velocity. Vectors can be added together. When two vectors are along the same line or they're collinear, the magnitudes can simply be added or subtracted depending on their directions. However, in two dimensions, vectors are added by adding their components along the x and the y, or the horizontal and the vertical axes. We'll take a look at this in the next lesson. Some common vector quantities and their scalar counterparts. One that is used interchangeably is usually displacement and distance, but they are actually really different. So consider you walking to a local Tim Hortons and back. To get there, you walk 3 kilometers north, you get your coffee and your donut, and then you return home 3 kilometers south. Displacement is defined as the change in the position from your final position to your initial position. So algebraically, delta D is equal to the final displacement minus the initial displacement. In this situation, you started at home and then you returned home. So in this situation, your total displacement would be 0 kilometers. However, there's no question that you did walk there and back. And so the distance traveled in this situation would just be the addition of the magnitudes of 3 kilometers going one way and 3 kilometers going the other, for a total of 6 kilometers. Again, notice there's no direction because this is a scalar quantity. It's very similar with two other concepts of speed and velocity. Speed is what we call the scalar quantity because we have no direction. And when we talk about velocity, it's usually speed with a direction. So let's consider that a car is traveling 60 kilometers per hour, and it has a speed of 60 kilometers per hour. But to understand the velocity, you'd have to consider the direction. If you have a car traveling at 60 kilometers per hour in the westerly direction, it's actually going opposite to a car traveling 60 kilometers per hour east. And that is the difference between speed and vector and our scalar versus vector quantity. So let's take a look at some of these examples. And I just want you to be able to identify each of these as either a scalar or a vector quantity. So here, the distance of 45 kilometers, there's no direction, so this is a scalar quantity. The velocity of 12 meters per second east, this does have a direction, so this is a vector quantity. Temperature, again, no direction, so this is a scalar quantity. Force, 25 newtons up, that is a vector quantity. Speed of 80 kilometers per hour, no direction, so this is a scalar quantity. And then finally, we have displacement of 5 meters in the northern direction. So this is a vector quantity. So if you're working on your document or if you have your page printed next to you, go ahead and fill in, explain in your own words the difference between a vector and a scalar quantity. Once you're done that, we're going to move on to the next example. In example 3, we're going to look at drawing vectors. So you can do this on graph paper or in space below. Draw the following vectors. By convention, vectors are always drawn with arrows. The direction of the arrow is the direction of the vector. Directions such as northwest, up, or to the right are positive directions. And then directions south, east, down, or to the left are considered negative directions, and we usually add a negative sign. So let's see how we would draw a vector A that represents 4 centimeters to the right. What I'll do here is I will go into the box. I'm going to go up to Insert, and I'm going to draw. And here I want to make sure I select a line. It's got to point to the right. So I'll put an arrow tip on it. And I will make this a little heavier so we can see it. And then typically what we do is we label over top the vector what the magnitude is. And in this situation, it was 4 centimeters. Great. We'll save and close, and there's our vector drawing. So let's do that again with vector B, which is 3 centimeters up. Again, I'm going to go up to Insert. I'm going to insert a drawing. I'm going to choose a line, and then I'm going to pull it so it's vertical. Again, I'm going to put an arrow tip on it because it should point in the direction. 3. And then add a text box and put in the magnitude. And in this case, it was 3 centimeters. Go up and save and close. And there you have vector B. Last one, vector C, has a little more to its direction. So we'll insert again. We'll go down to drawing. We'll add a new drawing. And this time, the vector points in the direction of down 45 degrees to the left. So when I draw my line, I want to start heading down, then I want to veer off to the left. Now, it doesn't have to be exact. We'll come back to that in the next lesson. But for now, we just want to make sure that it is off center, pointing in the down direction and off to the left. So we're going to put a text box again beside your vector. And this one was 5 centimeters. There, save and close. Okay, so let's go on. Vector addition. So vectors are collinear when they lie along the same line. And if they're the same direction, we can go ahead and add their magnitudes. But if they are in the opposite direction, we have to subtract their magnitudes. So let's take a look at these examples. So 4 meters east plus 9 meters east, there's both the same direction. And so we can just add the two magnitudes of 4 and 9. So if you've forgotten here, let me make sure I remind you. Go down to Insert. You can go Symbols, Equation, and I will just type equals. And I will add 13 meters. And then make sure I still have my direction because it is a vector. Okay. Similarly, over here, for B, I have 22 kilometers south plus 17 kilometers south. They're the same direction, and so I'm going to add the magnitudes. So that will equal 39. Let's type 39. This is kilometers, and the direction would be south. Okay. So let's take a look at what we do when they're in the opposite direction. So in this case, we have 10 meters to the right and 6 meters to the left. So we don't have the same direction. And what I want to explain to you is that here, 6 meters to the left, so I'm going to add it, 6 meters left is equivalent to negative 6 meters right. And so what that allows us to do is then subtract the magnitudes. So we will have, I'm going to use an equation, 10 meters to the right. And this time I'm going to write minus the 6 meters to the right. And that's going to equal 4 meters. Again, don't forget your direction. Right. I'll use a capital R. So there you go. Similarly here, 55 kilometers north, but 40 kilometers south. I'm going to go ahead and again show that 40 kilometers south is equivalent to negative 40 kilometers north. So what that allows us to do, I'm going to add a new equation, and I'm going to have 55 kilometers north minus 40 kilometers north, and that equals 15 kilometers north. All right, and there you go. Take a look at some other examples. So here we'll start talking about vector and scalar word problems. So if two hikers walk east 3 kilometers, and they stop to have a drink of water, and then they walk another 5 kilometers in the easterly direction, what's the distance they traveled, and what's the displacement they traveled? Well, again, for their distance, because we're just asking for that scalar quantity, we just add the magnitudes of 3 kilometers plus 5 kilometers, and that's going to give me 8 kilometers. However, when we talk about the displacement, we have to consider the direction. So here, I will have to consider writing 3. I'm going to use my equation. So let's use 3 kilometers east plus 5 kilometers east, and that's going to give me 8 kilometers east. So in this example, the magnitude of each distance and displacement is 8 kilometers, but the displacement being a vector quantity really needs to have that direction of east. All right, let's take a look at a car. The car drives 12 kilometers north. The driver realizes that she passed the building she was looking for, so she has to turn around and travel back 7 kilometers south. So what's the distance and what's the displacement? So again, the distance being a scalar quantity, let's turn the bold off. The distance is found by just taking the magnitudes, which is 12 kilometers, and adding them together, plus 7 kilometers. And that's going to equal 19 kilometers. But the displacement this time we have to consider the directions. So here we'll have to, again, let's enter a new equation. We'll have 12 kilometers north. Right now we'll add 7 kilometers south. We want to rewrite this with the same direction. So that'll go to 12 kilometers north. And instead of 7 kilometers south, I'm going to write 7 kilometers. I'm going to write, sorry, negative 7 kilometers north. This then equals 12 minus 7. That's going to give me 5 kilometers north. So let's take a look at another example. A cyclist travels 6 kilometers west, then 4 kilometers west, and then 10 kilometers east. So find the total displacement of the cyclist. Sketch a vector diagram to demonstrate this motion. So what I'm going to do here is go straight to a drawing. And I'm going to try and draw and sketch a vector diagram. So in the starting position, a cyclist travels to the west. So I'm going to put an arrow, point the arrow here, and that first distance that was traveled was 6 kilometers. But then the cyclist travels another 4 kilometers. And I'm going to put an arrow on that one. And I'm going to put a text box at the top of that one, and that will be 4 kilometers. So again, I'm showing my vectors as arrows, and then I put the magnitudes over top. But then we turn around and the cyclist travels 10 kilometers east. So I'll put another line, and in this case, we're going to go back in the easterly direction. Again, put an arrow and a text box. And this will be 10 kilometers. So there's a sketch of my vector diagram right here. And now we'll actually put it together as a equation. The displacement is going to be, I'm using a new equation. We're going to have 4 kilometers west plus 6 kilometers west. We're going to subtract 10 kilometers west. That's a negative 10 kilometers west because that's the same thing as 10 kilometers in the easterly direction. And so here we have it equal to 0 kilometers. And we should still, even though it's 0, we'll still include the direction of west. All right, so that takes us through our lesson. You can go back in our Google Classroom and you have the worksheet to do that corresponds to this lesson. If you have any questions, don't hesitate to reach out, and I will see you in our next lesson.